Hello everyone, how are you doing? In short videos we're going to talk about series. Okay, let's see what is a series. In last video we talked about sequences. Sequences is a set of objects, and that object gonna have a pattern. Whatever this area is, this will be doubled, this doubled the second one, and this doubled the third one. That's called a sequence. Sequence can be in numbers, could be 2, could be 9. How did I get from 2 to 9? You will realize it in a matter of seconds. Did you see what is in my mind? Not yet. Did you see what is in my mind? This is 7. This is 7. This is 7. 30. This is a sequence, is a set of number that is have a pattern. That's called a sequence. Power is 0. 1. I take this one and multiply by x. I take this one, multiply by another x. I take this one, multiply by another x. I take this one, multiply by another x. Take this one, multiply by another x. This is also called a sequence of objects. But sometimes this sequence can become a story. The TV gonna decided to run 45 minutes of this story tonight. 45 minutes the first following week. The following week another 45 minutes. And it's gonna keep going till it finish the story. They call this one a series of a short movie that altogether when you add it up, it becomes a total story. Therefore, if I take x to the power of 0 and add up the first term, that's become a series. That's the series. Maybe if I add the third one, that's also a series. See, part of the story tonight, part tomorrow night. Part tonight, tomorrow night, the following night. Tonight, tomorrow night, the following night, and the following night. This pattern can go indefinitely. But this is called the sum of part of these. The sum of part of it. The sum of part of these. Then somebody said, how can I simplify this? I said, this is a sum of x to the power of n when n started from 0 and go all the way to 1. Therefore, you go in here and replace the n by 0 and sum up. Next after 0 is 1. In here you write the sum of x to the power of n from n equal to 0 to 2. This one is a sum of x to the power of n when n is started from 0 to 3. And that's going to have 4 terms because including 0. But instead of writing the word sum, we use a letter, the Greek letter S. And this one called the index and lower index and the upper index, x to the power of n. Would you tell me what is that number? That number is a finite number. You see the end of it. That's called a finite series. But there are many cases that you start from n equal to 0 and you go all the way to infinity. And that called x to the power of n. But remember, I'm not going to use x all the time. What did we use to represent the sequences? We use ace of n. And what did we use to define the sequence? We use it explicitly and say this one is, for example, 1 over 2 to the power of n. And in here, I can start from n equal to 0 and write a set of number. 0 is 1, 2 to the power of 0 is 1, 1, 1/2, 2, 1/4, 3 is 1/8. Therefore, when I represent a sequence, a series, I use a sub n, and in here I'm going to write when n is equal to 0 to finite number. Therefore, that could become a finite number like 5, like 6, like 7. This is called a finite series. But if I change this one to infinity, that's called infinite series. Sometimes they said, can I replace this one by a b? You're perfectly fine. Can I write the sum of the series? And basically what it is, you're writing the sum of the term in the sequence. When n started from 1 to 5. Somebody said, what does it mean? If your sequence is n plus 1 over n squared a plus 1. This is what it meant. Put 1 here, you get 2 over 2. Put 2 here, remember n have to be an integer number. Put 2 here, that becomes 3 over 5. Put 3 here for n, that's 4 over 10. Put 4 here, that becomes 5 over 17. Put 5 here, you get 6 over 26. Therefore, basically this is your sequences, but I'm taking 1, 2, 3, 4, 5, the first 5 terms of the sequence, and I'm going to sum it up. And this is called a finite series. And somebody said, why do I have to know that? Okay. I gave you an example a few minutes ago that maybe I have the sum of x to the power of n started from n equal to 0 to 7. And let me do something right here too. I'm going to take this one also and divide it by n factorial. And just don't worry about the n factorial right now. I just throw it in there. Then I'm going to go to my graphing calculator and I'm going to say, oh, you know what? I'm going to go to mode. I'm going to change it to function. And I'm going to graph something. I don't know. I'm going to graph e to the power of x. And I go to window, and this is a graph of e to the power of x. And see how close it is to the 0, because as x go to infinity, e to the power of infinity, that's e to the power of infinity, e to the power of negative infinity approaches 0. Therefore, I go to my window, and I said, okay, make my x go from maybe -1, maybe to 2. 2 is good enough, because I want to see some space around here. Therefore, I don't think I put the data. See, I went to 0 to 2, And let me see, what did I do? No, and my x, I'm going to go from -3 to 3, 1. My y, -1 to 2. Let me see if I got any better. It's not bad. It got a little bit better. And remember, e to the power of 0 is 1, because each of these tick mark was half a unit. Okay. Somebody said, why don't you put n equal to 0 here? Well, x to the power of 0 is 1. N factorial, when it's 0 factorial is understood is 1. Therefore, when n become 0, you get x to the power of 0 over 0 factorial, and that's 1. And I'm going to graph y equal to 1. I'm going to see, goodness, that one and e to the power of x, they do intercept. Therefore, tomorrow if I ask you, what is e to the power of 0? I said, I don't know. But when x is 0, y is 1. You can use this function instead of that function. But somebody said, what happens if I have e to the power of 0.1? E to the power of 0.1 is different. I said, I'm going to add another term. I'm going to make this one a 1, and 1 factorial is 1. I'm going to put plus x. See, that 1 plus x is tangent to my graph. Therefore, what it is said from here to here, that series converges to that function. Then from tonight we got to learn, does the series converge or does it diverge? I'm going to say yes, it's converged from here to here. The rest of the story is diverges. Somebody said, make the convergence a little bit more. When x becomes 2, 2 factorial is 2. I add x squared divided by 2. What I see right here, I just increase the convergence. And somebody said, ooh, from here on it converges. I said not on, because I don't have many y value here. If I go and change my y value to 5, then you see it really doesn't converges to all. It converges to some. Therefore, as I move on, I have a circle, and that radius of a circle determines the radius of a convergence. It's telling you from that center how far go to right, how far go to left. And somebody said, can you increase that radius? I said, yes, I'm going to add another one. And I'm going to put plus x cubed divided by 3 factorial. That's 3 factorial. You go to math, backward to probability, and number 4. That's 3 factorial. All I did, I increases the radius of a convergence. Look at how beautiful this is. Then tomorrow if somebody asks you, what is, let me put the 3 right here. And if I said 3 factorial is 6. Somebody said, what is e to the power of 1.2? I said, God, I have no clue. But 1.2, if this one, let me see my tick mark. These are 1 tick, every tick mark is 1. This is 1, 1.2 is right here. Why should I use this function? I put 1.2 here in this polynomial. Whatever that answer for the y value of a polynomial is, I replace it for that one. Then eventually, I am going to take some of the series and I'm going to tie it to some of those most complicated functions. And instead of evaluating those complicated functions, for example, if I ask many students, what is cosine of 1 radian? And let me go to mode and change it to radian. Cosine of 1 radian. Some student doesn't even know 1 radian is 57 degrees. and that 57 is almost pi over 3, and is radical and cosine of pi over 3 is 1/2. Then 1 radian should be 0.47 or something. 50, oh no, 1/2, and that becomes 1.4. 1 radian is 57 degree. And what is pi over cosine of pi over 3? Cosine of pi over 3 is 1/2, which is 0.5. Why this one is 0.54? Because that's 1 radian, and I'm using cosine. Cosine of 1 radian, that's 0.54. Okay, if I take 360 divided it by 2 pi, each radian is 57 degree. Okay, 57 degree is less than 60 degree, and cosine of 60 degree is 0.5. Oh, 57. Oh, that's a cosine. Cosine is before. I'm sorry, I just my mind doesn't work. Therefore, as the angle get larger and larger and larger, cosine shrink. Therefore, 57 is first and 60 degrees second. Therefore, from 60 degree, the x have to be less, and that's right. 1 radian is 0.54. and pi over 3.5. But somebody said cosine of 1. I don't know 1 radian, 1.5 radian. Well, I go in here and put cosine of x, and I'm going to graph it. That's the graph of a cosine. Somebody said, can you change my window? I said, yeah. I go from -10 to 10, and I'm going to make this one from -2 to 2 with a scale of 0.5. That's the graph of a cosine. Somebody said, you know what? 1 radian, 2 radian, 3 radian, 1.1 radian is not hard. It's hard for me. Can you make some easy function? I said, I know. Cosine is an even function. Even means you have to use even number. And 0 is an even number. Therefore, I'm going to put 0 right here, and that become 1. Therefore, I press 1 right here. See, 1 and the cosine, they looks good. They intersect. But what is the next one? Even means it's x squared. Therefore, I'm going to write here, I'm going to tell you why I put negative later on. That's x squared divided by 2 factorial. Look at what happened. I put negative because it's concave down. See, the graph was concave down right here. And see, it matches cosine now. But somebody said, I need some more. But right now it's going to become concave up, and one end coming down, the other one had to go up. Therefore, I need a power of, or maybe power, that's the cosine is an even function. I put plus x to the power of 4 divided by 4 factorial. I'm going to graph it. I'm going to see, ooh, I have 1 minus x squared over 2 factorial plus x to the power of 4 factorial. Look at how beautiful that polynomial matches the graph of a cosine. Therefore, if I want to find what is cosine of 1 radian, I'm going to put my 1 right here. And I said 1 minus 1/2 plus 1/4. That's the cosine of 1 radian. Somebody said, what is the cosine of 2 radian? As long as the 2 is covered by that graph, but I don't see it. I see 1.5. You put 1 minus 1.5 squared over 2 plus 1.5 to the power of 4 over 4 factorial. And that should be 4 factorial. But somebody said, what happened if I want 3? You got to start adding. You have to start adding, and in here is a positive, it becomes negative, x to the power of 6 divided by 6 factorial. And see, it's going to cover up more and more and more. Then from today, you got to learn. We're going to take some pieces of the sequence. We're going to add them together. We create a series. And series will either be finite, if the upper index become a finite number, or if the upper index become infinity, that's called infinite series. Eventually, we're going to take those series and map it to many graphs and see how far these two gonna converge, the polynomial and the function. Then from tonight we have to know something about the convergence of a sequence, and we're going to test how they converge. Let's talk about a of n equal to 1 over 2 to the power of n. And let's write this one, the first few term. I'm going to start from 1. When is 1 is 1/2. When is 2 is 1/4. When is 3, 1/8. When is 4, 1/16. When is 5, 1 over 32. When is 6, 1 over 64. And I'm going to say, what is the sum of only the first term? I said 1/2. What is the sum of the first and the second? Is 1/2 plus 1/4. That's multiplied by 2, 3/4. What is the sum of the first 3? Well, the first 2 is 3/4. And the third one is 1/8. Therefore, 4, 2. 4 and 2 is 6. Oh, that becomes 7/8. The fourth one is the first 3 plus 1 over 16. I multiply by 2, and that becomes 15 over 16. Oh, I want you to watch. 2, 2 minus 1. 4, 4 minus 1. 8, 8 minus 1. You see that the numerator and denominator, as I'm going forward, it might get a little bit approaches. Okay, then they said, how do you know if a series, if I write this one as a series, the series of 1 over 2 to the power of n, as n is started from 1, go to all the way to infinity. For example, what is the sum of the first 100 terms? Okay, I don't know the graph. I don't know how to write all those 100 of them, but my calculator is not updated. But I'm going to go to second stat least, and I'm going to find the sum. See, that's the sum. That's not the sum. Second stat, sum is number 5. And I'm going to find the sum of the first few terms of a sequence. I do my sequence on operation, number 5. And I said my sequence is 1 divided by 2 to the power of n. But in here I see x, I don't see n, because my mode is on the function. If you change your mode in sequence, then when you type in, it will gonna give you n. But you gotta tell the calculator what number you are replacing with. I'm replacing number for n. From where? From 1 all the way to 100. I want to know what is the sum of all those numbers. Oh, 1. What is the sum of all those numbers when it becomes 1,000? I don't think calculator is going to give it to you because lots of terms that you have to add, and it take a long time, overflow. But I'm going to make this one maybe 200. Maybe calculators do up to 999. I didn't want the graph. I need the answer. Let me see what happened. 1. Oh, let me see what happened if it was 10. 10. Oh, 10. 10. Oh, that's right there. Therefore, if from today you have to know if the part of the infinite series, part of it converge. Means, what happens if you do the nth number? Remember, n is not infinity. N is 20, 30, 40, or a million. Therefore, if I said the nth term is going to become 16, 18, 4, 2. I bet you that's 2 to the power of n. Because these are exactly the same as here. But the top is 1 less. That's the nth one. That's called the partial sum. And somebody said, what is the limit? of 2 to the power of n minus 1 over 2 to the power of n when n approaches infinity. And this one, you get infinity over infinity. Somebody said, I'm going to apply L'Hopital rules. You cannot apply L'Hopital rules here. L'Hopital rules is for function. But you can change this one to a function because you know the sequences and the function, if they are same, they overlap with each other on the integer, but the function fill up the gap. But no, the sequence is only the integer. Therefore, I'm hoping that infinity become an integer number and that become infinity over infinity. Right now I can apply L'Hopital rules, which is 2 to the power of x itself times natural log of 2 minus 0. This is 2 to the power of x times natural log of 2 and is 1. And what is the limit of 1 as x goes to infinity? And that should be x is 1. And we are getting 1. Therefore, we have to know if the series is infinite series, maybe add the first 2, then the first 3, then the first 4, then the first 10, and see what those term, what kind of a series is gonna give you. See, that's the partial sum itself is a new sequence. It does have a pattern. Therefore, you have to know this is nothing except 2 to the power of n minus 1 over 2 to the power of n. And from here, you take the limit and see what happens if that number, if the limit exists and equal to a finite number, therefore you better say the series converges. What did we say? We say converge. Converge to 1. Did I say it is 0.99999? I did not say that. I said it is converge to 1. But if I said, what is the limit of 2 to the power of n plus 1 over n squared as n approaches 1, then you can say, oh, my limit approaches exactly 3. Therefore, your limit here is 3. And you can do it from right or left, but in here is approaching 1 because you go to infinity. Okay, let's talk about series. We have many different type of series, but the most important find is maybe let me have that sequence. This is a sequence. And I'm going to have the first 5 terms. Starting from, I cannot put n0 here because you cannot divide by 0. Your n must start from 1. Therefore, when it's 1, you have 1 over 1 minus 1 half. The next term, 2, 1 half minus 1 third. When it's 3, 1 3 minus 1 4. The fourth, 1 4th minus the fifth. You can keep going till you where? Till the nth part. Okay. Then I'm gonna go add these to make a definite series. Somebody said, what is a definite series? Is the sum of 1 over n minus 1 over n plus 1 when it started from 1 and go all the way to infinity. But let me see what happened to that one. I'm gonna go all the way to n right here, or whatever that number is. I should have put n in here. I should have got n equal to m or whatever. But when I add them, see, this cancel. This cancel. This and this cancel. 1/5 and a 1/5 cancel. But when it n become equal to n minus 1, what is it? That become 1 over n minus 1 minus n minus 1 plus 1. See, that become 1 over n. And that 1 over n and that 1 over n is gone. Then what is left is 1 minus 1 over n plus 1. Only the first one and the very last one. If it's 100 term, that become 101. If it's 500, that become 501. And if you take the limit as n approaches infinity, that become infinity plus 1. And what is 1 over infinity? 0. This one does converge. And this is called a telescope series. Telescope, like you have this one, you have this one. See, you can push it and they all the way become, at the end you have only the first term and the last term, and you can push it through, and that should be a negative. Push it through, and this is called a telescope series. Somebody said, okay, how do I know a series is a telescope series? Would you combine these? n plus 1, you put n plus 1 right here, minus n. This one is nothing, 1 over n squared plus n. If you have a proper fraction, do partial fraction decomposition. When you do partial fraction decomposition, then you may be able to see this is a telescope series, and you can apply the rule of telescope series. Another one we have is geometric series. What is a geometry? Geometry, everything is about similarity. Therefore, if these angles, corresponding angles, are the same, therefore the ratio of these to these must be the same as ratio of these to these, and must be the same as ratio of these to these. Therefore the ratio, like 4 over 6, the next one must be 8 over it, that's 2/3, and that become 8 over 12, and that's to become 12 over 18. That's the ratio. Therefore, if you take a number and say that's my first number, multiply by ratio. Ratio could be proper fraction, negative proper fraction, that's not proper, negative 2/5. It could be negative 7/8. It could be a proper fraction, positive or negative, or it could be improper. 1, negative 1, 2, 3. Somebody said, what happens if it's 2? Take that number and double it. Means 2 over 1. Take this one and double it. Multiply by 2 over 1, 20. And double it. And double it. Then what is 80 over 40? 2. 40 over 20, 2. 20 over 10, 2. 10 over 5, 2. That's the geometric series, sequence. But if I add them together, that's called a geometric series. Basically, this one has 1, 2, 3, 4, 5. I started from 5. And I started, my ratio was 2 to the power of n. But I got to get that 5. Therefore, this has to become a 0, because 2 to the power of 0 is 1. Therefore, your n has to become 0 all the way to what? 1, 2, 3, 4, 5. Therefore, I have 0, 1, 2, 3, 4. And what is 2 to the power of 4? 16. What is 16 times 5? 80. Somebody said, what happened if I started with a 3 and multiply by 1/2? It becomes 3/2. Multiply this by 1/2, it becomes 3/4. Multiply this by 1/2, it becomes 3/8. Multiply this by half, it becomes 3 over 16. You divided this by this is 1/2. This by this is 1/2. This by this 1/2. What is the geometric right here? From n equal to 0, because I need to start from here. But somebody said, I really want to start from here. I said, come on, man. This is the same as 3 times 1/2. I really want to start from right here. This is really times 1/2 is square. All of them have 3. Let's start from a 3 and put 1/2 here to the power of n and start from 0. If I put infinity, that's called indefinite geometric series. If I put 5, they call it a finite. And somebody said, how do you find the sum of all that? Remember, I have an n here. Therefore, 0, 1, 2, 3. That's make it 4 term. Therefore, when I go to n term, start from 0, you have to go to n minus 1. That's make it n term. Be very careful. But if I start from 1, you can go all the way to n. Okay, how do you find the sum of geometric series? It's very easy. Let's say you started from a, and the next one you multiply by r. That become AR. The next one you got to take this one and multiply by r. That become AR square. Then you take this one and multiply by another r. Therefore is AR square, AR cubed, AR to the power of 4, AR to the power of 5, and you go all the way to AR to the power of n minus 1 because you started from 0. That's n term. And if I put a plus right here, that become a series now. What kind of a series? That you started from a, your ratio is r to the power of n started from 0, go all the way to n. Let me call this one an I. I said my integer start from 0. These are my integer. I start at 0 and go all the way to n. Okay. Then somebody said, I don't care about this. I need the sum of that. For example, if I have 3 to the power of 1/2 to the power of 0, plus 3 1/2 to the power of 1, plus 3 1/2 to the power of 2, plus 3 1/2 to the power of 3, plus, and go all the way to 3 1/2 to the power of 100, and I want the sum of all that. I said that's very easy, right here. You go to second stat, math, number 5, but you gotta write your explicit formula, which is your sequence, number 5, and you have to write your formula. Here was 3 times 0.5 to the power of n, but remember, you have to tell what number, what letter you are assigning the number to the n. What do you start? I start from 0. How many times? I need 100, then you got to put 99. If you put 100, that become 101. Somebody said, I like 101. I said, okay, that's the sum. 6. The sum of all those numbers are 6. Somebody said, why? Because really 3 times 1/2 to the power of 90, that's pretty much almost a 0. Somebody said, no, I don't like that. Show me mathematically. I said, okay, I'll show you mathematically. You want to add all these? Let's create a formula. That's the sum. But I'm going to take the top and multiply by r. I'm going to multiply all of these by r. And what happens if I put r of 0 times r? 0 plus 1 is 1. You get AR. What happens if I multiply this one by r? AR square. What happens if I multiply this one by r? AR cube. Therefore, you see, you multiply everything by r, and you multiply this one by r, become r n minus 1 plus 1. Then I'm going to say, please subtract these two. Remember, in algebra they said you can multiply both sides of any equation by non-zero constant. Then you say you can add these two equations and take that equation and replace it for any of these two. Is not going to change your solution. I'm going to subtract these two. And that is, when I subtract negative, 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 and a negative, well, this one doesn't have any term here. Therefore, you write the A. But this and this is gone, this and this is gone, this and this is gone, all this is gone. But remember, A sub AR n minus 1 came from, I am adding 1. Because it was n, and then n minus 1, then I added 1. And right now this become what? And that become n minus 1, and with that one cancel out. But this one is a r to the power of n. But what are you trying to do? I'm trying to solve for s. 1 minus r. equal to a 1 plus r to the power of n. Then tell me what is s. Is your a, because I factored the a, 1 plus r to the power of n over 1 minus r. Somebody said, okay. I started with 3. My r was 1/2. And you said you want up to 100 first item, because I'm starting from 0 right here because 0 is there. Therefore, I have to raise this one to power of 101 divided by 1 minus 1/2. What is 1/2 to the power of 101? 0.5 to the power of 101. I think I did put, no, I need, because remember right now I'm putting my n, and n, I started from 0, go all the way to 100. Therefore, I'm looking, I have 100 first, I have 101 item right here, because that's included, 0 all the way to that one. That's this, plus a 1, times a 3, divided by 1 minus 1/2 is 0.5. I got 6. Therefore, you need to know this formula, a 1 plus r to the power of n over 1 minus r. You can use this one for any geometric series as long as you start from the start to the end. Somebody said, what happened if I want to sum from n equal to 5 through 10 of 3 to the power of 1/2 to the power of n? Well, some calculator, if is good, it does it. But this is 5 through 10. When in the fifth term, the initial conditions are different. Therefore, in here you have to say, I'm going to do it if I start from a 0. I'm going to start from 0, go all the way to 10, and 3 times 1/2 to the power of n. But I only need 5 through 10. I don't need the 0. I don't need the 1 and a 2 and a 3 and a 4. Therefore, I'm going to subtract from n equal to 0 through 4. See, 0 to 10 is 11. 0 to 4 is 5. You have 6 terms left. 5, 6, 7, 8, 9, 10. Then you have to write 3 times 1/2 to the power of n. Therefore, you have to use that formula twice, from 0 to 10 once, 0 to 4 another one, and subtract them. Okay, but somebody said, what happened if I have the sum of a r to the power of n started from 0 and go to infinity? That's the infinite series. I said, okay, that's not an issue, because if your a is 5 and your r is 1/2, when this go to infinity, 1 over 2 to the power of infinity is 1 over infinity, and that becomes 0 over 1 minus r. Therefore, if your r is between 1 and a -1, and that become a proper fraction, as means the denominator is bigger than the numerator, like 3/5. When you go to infinity, 5 to the power of infinity is way approaches infinity faster than the other one, and it approaches 0. Therefore, if your r is between -1 and 1, they said the series converge. But if your r is greater than or equal to 1, like 1, if it's 1 and the number is 3, you say 3 plus another 3 plus, because your r is 1, plus another 3 plus another 3. Look at that. Add infinitely many 3 together. That's going to become a huge number. You become a trillionaire. But if it become 2, 6, 6, 6, 6, oh, become much millionaire a lot quicker. And put -3, -3, -3, you become poor a lot faster. And you multiply by -2, -6, -6. Therefore, if the number is greater than 1 or less than or equal to -1, this one gonna diverge. You have to know these about the geometric series, that does it converge, does it diverge, and that's how you have to check your convergence and your divergence for your series. That's extremely important. Therefore, if I give you some example right here, what is your series right here? 2/3 to the power of n. 2/3 is between -1 and 1. That's converge. -1/5. -1/5 is between -1 and 1. It's gonna converge. 5/6 is between -1 and 1. It's gonna converge. But somebody said, how about 7/6? 7/6 is bigger than 1. Diverges. Also is saying, how about this series? When n started from 1, go to infinity. So you know what? When I go to infinity, it becomes infinity over infinity. Because a trillion plus a 1 is still a trillion. But I don't know if this converges. I'm going to find this limit. But I have to write the limit of the function. And if this one has a limit as x approaches infinity, then it's going to converge. If it has a limit, your answer is only converge. But I didn't say to what number. What is the limit of, what is the derivative of that one? L'Hopital rules. 2x over 2x. That's again infinity over infinity. But what happens if I take the derivative? 2/2. 2/2 is 1. And what is the limit of 1 as x approaches infinity is 1. I bet you that number approaches 1. You better say, yes, I do have a limit. That infinite series converges. I did not say converge to what number. I did not say that. Then, if you go right here and you go to your sequence and say, I'm going to start from the minimum n of 0, that's okay. I have n squared divided by, on the bottom I have n squared plus 1, and I'm going to put this also in the parentheses, and I'm going to say my very first function, when I put 0, I get a 0 here. I'm going to put a 0 right here. You can put 1 or 2 or 3. Then if I go to the zoom and zoom 6 of it, I see those numbers. See, it's right here. When I put trace, see those numbers. I'm going to go to my y value. I'm going to say, don't give me all those y value. Go from -1 only to 2 with a scale of 0.5 to see those numbers. See those numbers? Boom! What number you're approaching? You're approaching 1. It does converge. It does not tell you what number. Does the sum of all those numbers is a trillion? I don't know. The sum of them is a billion? I don't know. All I'm saying, because it does have a limit, it does converge. Thank you. See you in the next video, and we learn how to test different series if they converge or they diverge.